web applications at the backend. So when it comes to the Spring Boot, right, it offers many features such as auto configuration and dependency management. Without Spring Boot, what we used to do, every time we used to write a tightly coupled code and we need to manage the dependencies. So dependencies as in objects that we created, right, that we need to manage it manually. So with Spring Boot, there is this technique called inversion of control. So where framework actually takes about managing the dependency, takes the flow from developer, and we can inject it at the places where we need it. So I think this is a concept. So with Spring Boot, we can also develop microservices. So can someone help me understand what is a microservice? So I would like it to be a bit interactive. So you can take a guess, even you need not be right. Hello, are you guys still there?
Yes, sir.
Yeah.
Yes, sir.
Okay. So can someone take a guess? What is a microservice?
Yeah, it is like dividing the business logics and running it in small units. Like,
You are right. Let's
yeah.
take okay one big application. So let's take you have one big chunk of code base. You deploy it as once. What happens when something breaks in between? You need to actually take down the entire service. I need to actually fix it. I need to bring it back. Or else, let's say when you have to scale your service, you need to scale the entire application instead of an individual okay individual actually business logic that you need to scale it for. Let's say you take a big application and you break it down into the smaller application to put it simple around the business areas, or else we call as domain driven design. Let's say authentication is a one service. Let's take a simple application like Facebook. Maybe friend suggestion is a one simple service, and then messaging is a one simple service. Okay, another service. You break down the application around its functionality. So whenever, let's say there are more number of people are using newsfeed right now, they're posting it. Maybe today is a Jan 1st or okay some festival in this region. So you actually have to scale the one individual service. Let's say newsfeed is a one service. You need to scale that thing. You need not actually scale the entire application for that. By this way, we are actually saving on the resources. So we can individually develop each service and we can individually deploy them. We can individually maintain them. So that's the whole advantage of a microservices. So Java offers this framework called Spring Boot, using which we can actually develop microservices. If you would like to explore it, there is this website called spring.io. If you go and explore it, you actually have a Netflix libraries. So you could develop microservices using Java Spring Boot Netflix libraries. So which helps you to scale the services individually and write individual microservices. And lately, Java has adopted reactive framework onto it. So if you look at it, lately Spring got this feature called Project Reactor, using which you can develop reactive applications. Let's say, to explain what is reactive, let's try to understand what is a blocking application. Let's say you're writing a network call. So you're actually calling a database. So Java follows this model called one thread per request. For every request that is coming to the server, you actually assign a thread. And unless the request completes, the thread is not relinquished. Let's say your server has a limitation of only 255 threads. Right now, there are 1,000 users. Until the first 255 users are served, rest of the users need to wait because their threads are unavailable. Let's say one request comes to my service and my request has to go to database And then once I get the response from the database, only then I can respond, which is basically a network call. So how can we limit it? So by writing non-blocking calls. So Java has this feature called completable future, using which you can write non-blocking network calls. But this something is actually not managed by the framework. So Java Spring actually came with a framework called Project Reactor. So using which you can write non-blocking applications, which is part of the framework itself. You need not manually manage it. So Java has brought this project reactor into this in the Spring Boot. And then from Java 8, you also got a functional features. So we have an object-oriented programming. So, and since we're talking about different programming paradigms, let's understand this. So why there is a need of a functional programming? So when we actually have a object-oriented programming. So object-oriented programming is something like you actually divide your program into objects and differentiate the functionality. But what's happening with Java? Let's say you want to write an object for everything. Let's say a very simple functionality you want to write, and for everything you need to create a class, you need to create an object, and you need to do in a very standard way. But this is making Java more verbose, like a lot of unnecessary code. What is the beauty with languages like Python and JavaScript? You need not actually create a class and object for everything. Let's say simple functionality, an action. An action is something you can actually create a method and you can actually pass it as a parameter in JavaScript. But what happens in Java? If you want to create an action, you need to create a class for it, you need to create an object for that, and then you need to pass it functionality. So Java 8 has uh, Java understood this as a problem with the language, and they went ahead and implemented this feature called lambda expressions, using which you can create anonymous objects which actually has methods you can pass around instead of actually create going with the regular templated way of creating an object. So this enabled Java to be functional. Functional programming is more or less like you deal with the functions. You need not actually associate functions with an objects. That's what Java 8 has adopted. So Java is quick to adopt new features into its ecosystem. It's continuously evolving since a very long time. And also from Java 9, they also brought reactive part of their Java 9 in not just that uh, framework developed by some other company called Pivotal. Pivotal is a separate company which actually develops frameworks like Spring. If you go to spring.io, they actually use the language Java and started developing these frameworks. And I think with the evolution of the Spring and new Java features, it's still made relevant. And also, other reason for Java being so relevant in the market is that it has been there for a long time, and a lot of enterprise applications have been written in Java. Let's say if you take Amazon, PayPal, all these companies have a lot of these code bases in Java. It involves a lot of cost to migrate their existing code base. Java is scaling really very well. It's adopting. Let's say the number of developers, and there is a lot of community support for Java. So you go ask a question about Java, there are 1,000 developers. You want to hire a resource of backend development for Java, you get many resources. But let's say if there are there are equal advantages and disadvantages of the other languages. I mean, in a way that you need to choose a language that solves your problem better. But in a way that there's a soft influence of number of developers that are there in the market and what is the community support that you're going to get with it. And also Java is secured. If you see a lot of bank applications, they are written in Java. Even today, Java offers strong encryption techniques and strong actually compression, decompression techniques, which actually helps you secure your data across the network. So a lot of security algorithms have been implemented in Java. So using which you can write a lot of secure applications. And also, most enterprises prefer Java over other languages such as Python. So Python is relatively slow. You can write data related applications using Python. But when it comes to enterprise applications, you have millions of users you're using your service. Let's say Amazon, and you get millions of users using at any time, and you do not want your application to load slow. So the speed is okay. Performance is one of the factors, and also strong security mechanisms. I told, and also it offers features such as like okay, object oriented and functional and reactive. So non-blocking features right currently does brought in. It's still making it relevant in the industry, and the strong community support and number of developers that are there in the market. There are many tools that are built over Java. So the entire ecosystem around Java is making it more relevant. And also, there is actually growth in other languages meanwhile with demerits of it. Eventually, Java is picking up those features too. And slowly, we could actually see the growth in it. And coming to so Spring and Spring Boot actually are meant majorly for cloud related applications. So you can write services, microservices, which you could deploy them individually and then scale them individually and maintain them. And all this is possible with the evolution of the Spring Boot. And I think uh, these are the reasons where you need to choose backend development with Java. And one of the reasons you need to definitely explore it. And this is on why Java is relevant. But on the other side, why Java is relevant, maybe as a student, why you need to learn Java is that one is the number of jobs you're going to get in the industry are a lot more when you learn the language like Java. So Java is relevant in a lot of places, and learning this, which makes you employable. And I'm not just saying that you need to focus on learning a language. So language is basically a tool at the end of the day. Right now, I'm not working on Java. Right now, I'm working on different tech stack, maybe C Sharp. I might be working on React, or I might be working on JavaScript. At the end of the day, you actually try to solve a problem, and whichever the language that actually fits the problem, you could actually choose it. So I chose the topic Java because Java is widely used compared to other technologies around the industry, and it has been there for a very long time. And I think there is a question in the chat, sir, how is microservices different from modular programming? Uh, so I didn't really understand what do you mean by modular programming. See, as I explained that, okay, microservices basically like you actually divide one big service, one big code base into granular services around their business domains. I took an example of Facebook for you. A newsfeed is a one service, a messaging is a one service, an authentication is a one service, and then let's say Reels. Okay, maybe it's part of the newsfeed itself, and then friend suggestions is a one service. So all these are different business domains within the same applications. We divide them and scale them individually. So why we need it? Let's say on particular day, I said you that okay, let's on a new year, there are a lot of posts or there's a festival going in the region. So I think there are a lot of users using particularly newsfeed, and on that day you need to individually scale it. You can't scale your entire applications. If you scale the entire applications, you need to actually invest on more number of servers and more resources. You're actually saving in terms of cost. And also, microservices is not a one-stop solution for everything. It depends upon your use case. Let's say you actually write a lot of granular services and you write 100 different services and you did not actually set up your ecosystem right, and there involves a lot of network calls in between these microservices. This indeed makes it slow. So you need a proper architecture in place, proper ecosystem. How do you let's say if something goes wrong in the call, like one microservice might call different microservices. Yeah, how do you actually trace? You should be able to have a distributed tracing in place. So for that, you need to have distributed tracing. Like in Spring, you have a sleuth is a service. You have a trace ID. You can get the entire chain. And what if, let's say there is a chain of microservices, right? Okay, service 1 call service 2 service 3, and if service 2 fails, the call to service 3 doesn't happen. How do you handle it? The fallback mechanism should be in place, so that if one fails, we just need to fix it only without going to the trouble of whole management of the service, right? Yeah, exactly. See, let's say uh, you're using Facebook. Let's say if newsfeed isn't working, there's some error with newsfeed. So if that actually stops even your messaging service to fail, okay, it makes even your messaging to fail. Does it make sense? You can use a messenger even without actually having to rely on newsfeed. So you, based on the individual feature and business domain, you separate them out. Each of them, it looks like a one single application, but in reality, they are separate services. Like friends recommendation is one service. Let's say you can't able to see your current friend list, or you can't able to get a current recommendation of the friends. That's fine. It's not a critical application. But if it is stopping you to see the news feed, if it is stopping you to see the messenger, that doesn't make sense, right? Okay, that's where the advantage of the microservices comes into the picture. So using Java, okay, you can write microservices uh, with the help of Spring Boot, okay, which would help you to bootstrap your application, because a lot of auto configuration. A service would require a lot of configuration. You can go to spring.io and just say the libraries, okay, the dependencies you need, you configure it and you download it and you load it into your IDE, and then boom, you're done. It's very quick to develop using Spring Boot. So for that, you need to explore if you're using, and if I have to talk a lot about microservices, it's going to be one another talk where I need to talk about what are the solutions using which you can develop. One is Spring based solutions, or else you can actually, okay, framework based solutions, or else you can have something like even solutions provided by your cloud service provider. Let's say if you're using AWS provides its what to say own Dockerization and also own load balancer. But if you move from AWS, okay, there's something like if you want to move from AWS to Azure, you need a common solution that fits. Maybe you can go for what to say cloud native solutions like Docker, Kubernetes. So using this, you can deploy your applications anywhere and scale them. These are solutions, but we are deviating from the original topic, which is why Java is relevant. And I think these are the reasons why you need to explore Java as a backend for your backend development. And it's very easy to learn, and it would be useful for you a lot. Let's say in a lot of interviews these days, you'd be asked a low level design. I think Java is the one application where oops is at everywhere. So you could learn low level design when you're starting developing in Java. So how you could write loosely coupled, extensible, and encapsulated code using Java. Explore that. So that would help you. That would add one more skill into your basket. Okay, I think uh, this is my experience with respect to Java. So if in case you guys have any questions, please shoot. I'm ready to take in Q&A. So there is a question from Himanshu Shekhar. What is the right hierarchy of learning backend stuff, including DevOps, Kubernetes, and all these frameworks? It's kind of confusing. Might be a silly question, but yeah. I think don't directly jump into this. I think one, uh, if you want a roadmap for this, start with the language, start with the framework, and then think about how you can actually containerize these applications, maybe Docker, and then you learn about how to deploy them, and then think about scaling them using Kubernetes. You should also know about CI/CD pipelines. So the roadmap is this. You learn, okay. So also learn Git. So I'll say this. Okay, learn a language, learn a framework, learn Git, learn how CI/CD work, and then how you can learn how you can actually containerize your application, and then learn about some cloud where you can deploy your application, and how you can scale that application using Kubernetes. So this would actually answer your entire flow. Hope this answers. Hi, yes, anything else? Open source contribution or CP. See, open source contribution or CP, I don't think much relevancy to any employer. See, any employer would like to see a proof of code. If any employer want to hire you, what you're bringing to the table. So let's say you have a bunch of projects on your resume, a proof of your work, and you have a GitHub profile where you actually host have your code base, and also you have hosted your application somewhere where you can demo it. So there's always better to have work that shows the proof of your work. And when it comes to CP, yes, initial rounds, right? For these companies, they test you near DSA. CP can help you in clearing OAS, because when you sit for placements on day zero, maybe Microsoft or Google, when they're hiring, there's going to be a lot of competition. So they have, okay, when there are a lot of applicants, they need to filter out the best among them. So then CP can help them to filter out the best candidates. But once you clear that round, okay, next round's a DSA. You need to have strong problem solving skills. I personally did not do code forces or code chef. I only did lead code. That helped me. An open source contribution, yeah, you can very well do. That is actually that adds brownie points. But I prefer mostly having your projects live somewhere, and also you have a GitHub profile where you can showcase your code and as well as a project. That actually gives a um, that adds more value to me.
Hi, can I add a little bit more to it?
Yeah, sure thing.
Like open source in the first place looks like a little bit intimidating to be honest, because for CP or lead code, there's a structured roadmap to what to do. Okay, there's one easy questions, then there's medium, then there's hard. CP, there's a whole jungle of what you need to do, where you need to find open source projects, what do you need to do in them. So that's why I asked the question.
Okay, that makes sense. See, open source as in, see, let's say Apache is an open source library. They have many projects on it. So, uh, first, one thing you need to understand is that, so which area you'd like to pick it up. Maybe Google has Google Summer of Code. So where they actually welcome people to contribute to open source, like that even Mozilla has much. So what you need to do is, to be able to contribute to the open source, you should be well aware of the about the language that you like to work. And one thing is, you should be good with going through the source code that is available in public and should be fluent with reading it. You should be able to identify the bugs. See, open source contribution need not be that you actually bring great value to it. So some of the contributions are something like, okay, let's say, so one particular service is failing in an open source project. Maybe there's an error. You just debug it. It could be a simple null check that is failing for that. You actually go ahead and fix that, and actually raise a PR. And if your PR got accepted, you are actually shown as a contributor. You could simply go ahead and contribute, or it can be simple as a null check, or you could write something very complicated, okay, complex, that add values to the open source project. Let's say you have a Linux, right? Okay, Linux has a kernel, and okay, let's say a kernel is actually taking the current kernel which they have written might be slow. You could take the current code base and find out, okay, which code is actually causing a lot of performance issues. You could rewrite the code. You can refactor the code better. So using better data structures, algorithms, and okay, using best use of the resources, and you could raise a PR. So your PR is actually validated by the many contributors, and if they could see that your PR actually is bringing a value, they would accept it. That's simple as that. Okay, where to start and why to start? Okay, you need to find out. See, you just Google out. Okay, what are the current open source projects that are available, and try to see which language you're comfortable with, and try to go to their GitHub. Okay, and then okay, every open source projects have their okay GitHub okay repository. where
Yes.
they have a entire code base, and you can also go ahead and see who are the contributors and see that their PRs. So what PRs have been raised to that particular repository, what they try to fix it. And I personally think that it's easy to learn from other people's work than you going and exploring it. Then if you look at other people's PR, right, you understand this. So what they have contributed, what change did they do? You learn from other people. And also even in a CP, let's say code chef or code forces competition, you may not be able to solve you may not be able to write the best code. It's not passing all the test cases. Maybe after the hackathon, maybe after that challenge, right? You can, when the results are announced, you can go ahead and look at the editorial and see how other people have written. You can learn from other people's work too.
Exactly. Thank you. Thank you so much.
So, what's going in IIT Madras? So, you are from engineering background or BSc?
Yes, sir.
BSc or engineering?
So we are from BS degree.
Okay.
Yeah.
Okay. Any other questions back in development or anything with respect to software engineering, CP? I'm open. I think I just started off with Java. You're open to ask anything and everything. I'm happy to answer.
Okay.
Anyone have a question? I think there is no question, sir.
Maybe I'll ask you guys. Okay. How you guys are having fun? Too much? So what it's like to be an IIT and how you are coping with stress. So do you guys study a lot as a presumption of an outsider, or you guys enjoy?
So we used to study because it's we are having a lot of content here.
Okay.
Yeah.
Actually, sir, after tomorrow, I think there is a quiz, but there is a lot of people for attending your session.
Yes, sir. We are having our quiz too on
Okay.
birthday.
Welcome me guys sometime to your campus. I'm actually way too excited to come to your campus and meet you guys personally. Thanks a lot for having me, guys.
Yeah, sir, if possible, then I think you must come in campus for our hackathon.
So
Yeah.
we will approach you.
Thank you. I think there is actually a few questions, I think, in the chat.
Yeah,
Tell us
yeah.
about 4 years journey, start phase, challenges. See, guys, I'm not really from a very fancy college. I'm from a local tier 3 institute. So
Okay,
I think,
and it will be an inspiring story. So I think you should.
Yes,
yeah,
sir.
I
You
mean,
should. You should
yeah,
say
I
this.
think I would cut short. I don't want to bore you guys by telling you the entire stories. See, we have I mean, I started, okay, since I'm from CS background, okay, the best thing we had in the first year is CPDS. I mean, C programming and data structures. And for us, it used to be that blue screen Turbo C. If you are aware, we used to
Yes,
code
sir.
in that, okay? And if we could print the hello world there, okay, wow, that was awesome. The first program, okay, we have written is my name, myself. I just used to write it and I used to feel see during that time I think Android was evolving. I used to have this C compiler in my phone. So I open the book, okay, type everything and on that phone and compile it and also run it. Not okay whenever I feel bored. But anyway, that started giving me an interest to explore this. I think in 2.1 we have our data structures. I think it's only the tech stuff I'm talking about. Okay, I had good friends, and then besides that, we used to enjoy a lot. So I'm the most studious one because I wanted to somehow get into Google or Microsoft after my college, but that didn't happen. It took me a few years. But overall, I enjoy my journey. 4 years, I think. I think the second year, third year, I think I enjoyed a lot. I think is that fourth year the placement starts. Okay, that's when you come to have a hard reality. How you are. So whatever you thought, right? Okay, it's not a. It's a very distant dream, and you need to do a lot more. I think in my college I didn't do CP. There's no culture of CP at all. So you hardly find a guy who know hacker rank, forget about code forces or code chef. So I got to know it in fourth year. Okay, I just gave one challenge. So I did one challenge. I gave my code to my friend. He also submitted the same code. So we both got penalty. So we, then we got warned, okay, to not actually plagiarize the code. So
Okay.
that's where we learned about a bit of CPU. Okay,
Okay.
and
Can you tell me
then
the college name, sir?
my college is VJIT, Vidya Jyoti Institute of Technology, Hyderabad.
Okay. So continue telling
Yeah,
the
I
story.
got college placement. Sorry, what did you say?
You got a college placement?
No, I didn't get the college placement. Okay, the question I was reading. Okay, how did you? Okay, did you take college placements? Yes, Jude. Okay, I got a college placement. Okay, some what to say, startup, and they were asking me to sign a bond for 3 years, giving my certificates. I didn't take that risk. I actually started looking out opportunities outside. I think I took a break for GATE exam to get into IITs, but eventually I figured out my goal is different than getting into IITs or something. Then I figured out my path. I think everyone has their own journey. I respect that.
Yes, sir.
So was
So
Microsoft your first job? Oh,
no, I started with the service company, Virtusa, and
okay.
then I moved to Verizon,
Okay.
and then I moved to PayPal, and then Microsoft is my fourth company.
Acha.
So I mean, in a way that okay, after PayPal, I think I got calls from almost all FAANG companies. I think I had offers from Apple, Amazon, Google, and then Microsoft. Microsoft was my last offer, so I went
Okay.
ahead with my last offer.
Means you had a dream of joining Microsoft, or like why did you drop Google or Apple,
I
then
mean,
join?
I think anyways, okay, in job market, okay, you decide based on the team compensation,
Okay, yeah,
so the value. I think, and I also think that okay, it's the same for you in the placements, right? If you get multiple, anyways, your placement department won't tell you at the same level until unless you
yes,
get a compensation or a role better than that. If I'm not wrong, is that
right.
still there? Let's say you got a day zero Microsoft on day one. Okay, so Google, are you allowed? I don't think so. Same level company.
Yeah, no, I don't think so. That is it's
Yeah, that's there in okay. But anyways, fortunately I had choices, so I can really think which what works better for me.
so like you said that you didn't do CP and like you did only DSA.
Yes, I did. Okay, I didn't participate in lot of challenges. I only did lead code. So I
Okay,
think in pandemic I sat down. Okay, I think everyone were actually going out. Okay, every day I see they started this daily lead coding challenge. I started solving these problems every day, and then I got the gist of it. Got better at it. Anyways, okay, I used to attend classes every day, and I'm already good with the data structures and algorithm subject. But I never solved a lot of problems. That's all. That's the only problem. As I kept solving, I got good at it.
okay.
So my CP journey is not in college; it's outside of college. So there's another question. Okay, how much time it took to get into Microsoft? Okay, can you tell us more about your internship period? So I didn't do an internship at Microsoft. I was actually do okay. I mean, I did an internship in one company after my college, and then later I took a break, and then
And
I
about this
started
internship,
working.
can I ask one more question? Sorry. Like
I mean, is this recording necessary? I think you can turn it off right from here.
So it is necessary, I think. So it will further be uploaded on YouTube on our IITM YouTube channel. So
Actually,
it
a
is
lot of
Okay,
necessary.
it's
students.
uploaded on YouTube. Okay.
Yeah, yeah.
Yeah,
Uh,
actually, a
I
lot of
think I have
students.
some concerns about it. Okay.
Okay,
Wait
okay,
a second. I think, I mean, I got some notifications of work related. I think they could have been part of my screen share and recorded. Can we
okay.
actually look into it?
Yeah.
So we'll discuss it for offline. Okay.
Yeah.
So I'm working. Okay, I'm right now working for Bing. Okay, that's what I can tell. That okay, I can't further tell anything about what I'm working.
No issue, sir. You can skip this question.
It's okay, guys. Thank you. Thanks a lot, and have a nice weekend. Bye bye.
Sir. So
Yeah,
we would
anything?
like to thank you.
Okay,
So
thank you, guys.
on behalf of the entire team of Agobit, I want to extend a heartfelt thank you for your guidance and support, sir, throughout this session. So we enjoyed a lot. Thank you for sharing your invaluable thoughts and knowledges. Thank you so much, sir, for joining.
Thanks a lot, guys.
Okay. Bye bye.
Bye.
Thank you, sir.